Yes. So I did ask the LLM if I should upgrade everything, and it said yes. And then I asked, it was like, should I report back on known issues? And I was like, sure. And it told me some bugs with iOS 18. So that's kind of how things go. Um, let's see. It's been a while. So wait, how do I do that again is really about how to even talk. Um, but thanks, Matt, for tolerating me back. I'm Sam. I'm a security engineer on the corporate security team at DoorDash. Um, but I've only got 15 minutes, so I gotta get through things. But before I bore you with more LLM stuff that I'm sure you're sick of hearing about AI and all these things, I want everyone to have a takeaway from every talk that they see. And I just learned about this feature, which is part of macOS, where you can hide all of the icons on your desktop. So instead of cleaning up those 8,000 files that have been sitting there and like making that folder, dragging them in, which is then nested folders going back years and years, um, you know, go pull up this menu under desktop and dock, and you can uncheck show items on desktop. It's like the best feature. So everything else is about AI. But important features. Take that away. So, I saw the MacDevOps YVR X11, and it all going to 11. That makes sense to me. It's Spinal Tap, all this. But like, what really made me made me start thinking about was X11, like the windowing system and Xcode. So I was gonna be really ambitious and have LM write me a slideshow application that worked with X11 through Xcords, but I got a ways down there, but I heard there was some HDMI problems. I'm like, this is gonna be too problematic. So instead, um, I used the generative AI tools to make a bunch of X11 themed Vancouver Spinal Tap images. So these are users in our DevOps teams using X11, I guess. Um, but you know, I think that I'm not going to mention any specific tools, but I use them all because I don't, not because I can't, but just because they change so fast. But these are from two different um, models out there, which are quite popular. I think the one on the left is more reminiscent than the one on the right. I don't know about this guy in the upper right, in the right picture. Anyways, that's enough about that, right? But just, there's a lot of silliness. So, um, really, I want to go back and think about like where I kind of was a dozen years ago or so. I had a few tools in my toolbox, but you start out and you're like, hey, I'm a Mac admin. I know about, you know, imaging and Monkey and stuff, but it ends up being a very slippery slope where you start with this little toolbox and it snowballs and snowballs and snowballs. And thinking back, how did this happen? How did I learn all these tools? Why did I need to learn all these tools? For me, it all happened because I wanted to net boot that VM in ESXi, and we were on ESXi 5.1, and I needed 5.5 to do it. And I was told, well, just go update it yourself. And then hot potatoed that to me and many tools over the years. But eventually, like your toolbox becomes so large that you got to graduate beyond that like little toolbox you had or that Red Craftsman to you got this whole pack out, but you're not using all these tools all the time. Maybe you don't even remember what half of them are. You just kind of know about them. I don't have the capacity to carry around a giant packet all the time. I get the capacity to remember a few things at once. And the way that I've really started thinking about this is that as you progress through this like DevSecOps journey, your brain at some point has somebody come along and enable S3 intelligent tiering. This is like how I think my brain functions at this point. You start out and you're like, I can remember everything. It's frequent access. You know, if you're storing things in S3 and you're reading it back in the same region, it's free to read. There's cost to like egress it to somebody else, but you can keep recalling this stuff real fast. It's easy. But eventually you're like, oh, this bill's too high. Do I need to keep all this hot? No. You just go check this box. And then you don't access it for 30 days. It gets a little bit more expensive to access. It goes further along. You get like 6 months down the road and it's going to take hours for a call. It's expensive to read. It's not expensive to store, but as things come up, you're like, I know that I know the answer to this. I know that I know how to do this, but recalling it isn't just muscle memory. It's not just hopping on a bike again. So this is like how I've started to think about how my brain works and all that kind of thing. But there is one more tool that we can bring in our toolbox that might help us with this giant archive of information that we have about, hopefully not about ESXi anymore, but you never know. And that is the LLM, AI, whatever it may be. Don't worry, every image in here is just me typing randomness into prompts and things come up. So these tools, you're gonna have access to them. Maybe you're skeptical, but they can be the ultimate assistant. But they can also really be the devil on your shoulder that encourages you to do things that maybe you shouldn't, or maybe you shouldn't do them, but they're helping you today. And I kind of want to just talk through a few ways that I've used these tools over the past few months to help with problems. So here's the first one, the success. So in the past year or so, I've had to pretend that I'm a network engineer a lot. And when you're pretending that you're a network engineer, with the unfortunate reality of 2025, you're still going to be dealing with IP law listing a lot. And when you're dealing with that, you're going to run into things like capacity limits and security groups and be like, you know what, I can't have 16 like IP addresses as /32s because that exceeds the capacity. It'd be really nice to have some contiguous IP space. Now, if you're using AWS, they have a new feature where you can provision contiguous CIDRs of elastic IPs. And you pay a little extra for this. I think it's like an extra $1 per IP per month or something like that. Not very much. And that's great. But what if you're running somewhere else and you can't do that? The provider you're using doesn't support that, but effectively you're using something that functions like elastic IPs. You can provision a number of them, but you're trying to get 8 in a row. You can keep requesting, releasing, requesting, releasing, requesting, releasing. You don't know how many are out there. But with an AI tool, you might be able to describe this problem and say, hey, there's this API that lets me request this, keep track of it, release it. What should I keep? I can only keep 100 at a time, and there's 10,000 out there. Which ones do I do? So play this game of hide and seek, and with LLM tooling, you can certainly come up with some code that will allow you to get what you're looking for. You know, you're going to hold these IPs for 5 seconds at a time. They're billed by the second, but you get what you need. Should you do this? I don't know. It helps. But you do that and you're like, I saw this network engineer hat on, but you can't always succeed. So, you know, we've really invested in this DevOps approach where, you know, we want to manage things with tools like Terraform, but we're still running up against these limits in, say, security groups where you can only have so many CIDRs expressed in them. You end up with all these IPs all over the place, and you're like, I just want to reduce these to the smallest set of CIDRs that could exist for this. Now, ultimately, IP addresses are just numbers, and IPv4 it's a 32-bit number and 30-bit integer, and IPv6 is 128-bit. They're just integers. You're just trying to compress them to a range. But trying to do this in Terraform is not a sensible thing to do. Terraform's not good at math. HCL, the language that you use for Terraform, like the key word there is the C stands for configuration, not for computation. So trying to do this in pure HCL, not really achievable. There is a community module that supports doing this for IPv4 through a bunch of very interesting math. It works, but then somebody is like, hey, we should use IPv6 in our environment. Obviously that's me. And it doesn't work. So you have the same problem. You're like, hey, LLM, can you make this thing support IPv6? And it's like, LLMs are good. They'll tell you this is not a good idea. You're like, do it anyways. And it churns and it churns and it churns. And it gives you something that would work, but basically just melts your computer. Don't do that. So we're still at a failure state. I'm like, oh, I heard about Terraform supporting provider-defined functions. It's a new functionality where you can send some data off to a provider, which is actually Golang, and you know there's libraries there that can easily handle this stuff. But trying to loop this back, it's just hours and hours of LLMs hallucinating APIs that don't exist. Never got this to work. I just gave up. So that's the ambitious failure. I guess the learning there is really IPv6 probably still doesn't matter. But let's go into the load-bearing glue. So I think that probably everybody in this room owns some kind of glue code that sits between different APIs, synchronizing data, doing something important, but you probably don't touch it very often. And I don't know, about a year ago, I got an escalation that some new users weren't able to access internal systems. You know, we've got various code that does some automations to handle that. But it wasn't really clear what was going on. So we talked to the users and they're like, the users can't access the internal systems. Well, what is particular about these users? Oh, they're new users, the new employees. So thinking, you know, going back to the archive, and I'm like, oh, I know we own this service that does stuff like that. There hasn't been any changes to it, but I know how to go look at the logs. And what I find is that this code, which runs in AWS Lambda, has been erroring out the past few days. It's out of memory. So if you run code in Lambda, by default it gets 128 megs of RAM, and if the process uses all that up, it's just instantly killed. So if you deploy something and you're like, hey, this is grabbing information about all your devices, works fine, and then eventually you're going to hit some number of devices where you're going to run out of memory. So that's what's happening here. So I've got some example code here of like kind of what's going on. Super simple Python, got a source API, a target API, queries to get all the device IDs, then goes through all of those device IDs to get all the device information about them, and then goes and posts it to some inventory tool. What's happening is that this device details list ends up being quite large. It's all stored there, and then converting that all into JSON takes even more memory. So once you have, when you test it, when you wrote this 3 years ago and you had 100 devices, it was fine. When it ran for 2 years and it went to 10,000 devices, it was fine. But eventually you just crossed that threshold and it ran out of memory. Now, I don't have time to like figure out what's actually wrong here. Like, do we actually need to load all this into memory? Is there a more efficient way to do it? Sure. But I just need to fix this problem. So the last change that we made, because we deploy this through we've listened at this conference for the last 11 years that deploying things through configuration as code is the way to go. So this is how it's deployed. It's a simple Python file. Deployed through Terraform. Lambda has to take a zip file. The only thing in the zip file is the Python, the one Python file. So we go in, look at the code. We make one change, which is to declare the memory size. And we're like, I don't know how much memory this needs. 128 megs is fine for a while. We'll bump it to 1 gig. A few extra dollars on the AWS bill, not a big deal. This is a problem for another day. And that was like last summer. But then you get another escalation. It's the same problem, but this is a few months ago. You're like, there's no way that the memory use is the problem this time. We gave 8 times. There's not like 8 times the number of devices or users. No, there's a new problem. And that problem is time. Now, we can throw more compute at our lambdas. We can give it more memory. I think you can give many gigabytes of memory. We know we're not starved for CPU, but we're running out of time. And you cannot get yourself more than 15 minutes in AWS Lambda. So what do? Well, thankfully, we can use LLMs to help us here. So if we go back and look at the code, what does this actually do? It's making one API call to get all these device IDs. At the end, it's making one API call to post them somewhere else. But in the middle, it's making a series of API calls, one per device, to get all the device information. So one after the other, like that's our time. So we can speed this up. We know that the system that we're querying has some reasonable limits, like querying 5,000 a minute is fine, but we don't have to know how to do that. Now, I've made things multi-threaded in Python many times over the years, but do I remember how to do that off the top of my head? No. Do I know how to do it thread safely right off the top of my head? No. But I do have, I know what thread pool executor is, and I know I want to use that, but can I use this new tool of an LLM to do it? Sure. So I bring it over into the fancy new coding tool. I highlight the line that says for device and device IDs, and I say, hey, this is the API call here is slow. Update this to be multi-threaded. And within a minute or so, I get this back. Maybe there's a couple modifications that added a function. I didn't really want a function. Ultimately, it ends up looking exactly the same. I run it on my laptop. It goes from taking 15 minutes to run on my laptop to taking like 2 minutes to run on my laptop. I'm like, cool. We'll push it. go to deploy this with Terraform, but we hit a problem. We're running Python 3.7 in the Lambda because that's what there was, I don't know, 4 years ago when past person built this. Was it me? Was it somebody else? Who knows? Does it matter? It was long enough ago that it doesn't, there's effectively, it's in some archive. So we need to update the Python version. We can go look and see, oh, here's these deprecated runtimes in Lambda. The Python 3.7, what the deprecation was announced in 2023. You couldn't create Python 3.7 Lambdas after January 2024. So we're like, okay, this is at least that old. And you haven't been able to update Python 3.7 Lambdas since November of last year. So we know that when we updated the memory, it had to have been before November. Now we just can't change it at all. All we can do is change the runtime or delete it. It'll keep running for a long time, but we can't change it anymore. So we go and we look on our laptop and we're like, okay, we're running Python 3.13. We'll just like update it to that. We can see that that's supported until 2029. So like by the time this problem happens again, it's definitely somebody else's problem. So go in the Terraform and just change the runtime to Python 3.13. You know, Terraform applies it, job done, problem's over, right? It's not, because testing on we were running on our laptop, it was doing all the things, it was syncing these devices. We get another escalation the next week. Users can't access internal tools. And you're like, can we just be done with this already? Like, it's the simplest thing. What's going on now? You go look, and instead of your Lambda crashing after 15 minutes because it was out of memory, or out of time, it's now instantly crashing because it can't find the request module. And you're like, what? I didn't touch anything. And then you search and you find this blog post from 5 years ago about upcoming changes to Lambda where request is not going to be included anymore. In Python versions of 3.8 or later. You're like, oh, I think I remember why this was on 3.7 still. I guess we need to do something about this. Now, if we look in the text here, it says, you know, what should you do? You should either package the request module with the function or as a Lambda layer. Well, I don't know what Lambda layers are, so maybe we should package it with the function code. Like, I've certainly seen people do this, but it doesn't feel right. Our sync code is, you know, 100 lines. Obviously what I'm showing is like just an example, but it's pretty simple. It doesn't feel right to put an entire module next to our code and have, here's some git commit with tens of thousands of lines, and now I know that I'm issuing tech debt because it's whatever that request version was then, and you know, like it doesn't feel right. I've seen it. I don't remember. Like, my Mac is on Apple Silicon. It's ARM. I know Lambdas are an Intel by default, or is there some compiled code in there? I just don't remember. I don't want to deal with it. It doesn't feel right. So what are Lambda layers? Well, Lambda layers are just another way to augment code, have more code in that a Lambda can read, so you can decouple dependencies and have them be read. So I'm like, okay, well, I guess I got to read a little bit about Lambda layers, but you know, probably everyone was using this request stuff. So Amazon's clearly like have some official Python packaged Lambda layers. No, I don't have time to deal with that. So like I go look online and I see, oh, there's this community K layers where there's very common Python packages that are published as lambda layers. You can use them, you can reference them. But then I think to myself, this is some external dependency. I'm going to need to go talk to somebody about the risk of this, and they're going to be like, what's K layers? And I'll be like, I don't know, I scrolled down, it's Keith's layers. And I'm sure that Keith is a very nice person, but when the compliance team is like, is Keith going to sign our vendor document? I'll be like, I don't think so. So let's try to think of a different workaround. So I go talk to my LLM and I'm like, you know, I'm really only using like a little component of requests. Like, can you give me like a replacement for this so I can just depend on the standard library? And it prints out, here you go. Here's some code that you can drop in, and you don't have to change your code really at all. But now we're just going to depend on the standard library. I'm like, this is maybe a bad idea, but putting tens of thousands of lines in my repo sounded like a bad idea. Maybe this is less worse. So I end up with, after, I don't know, 15 minutes, some code, which I gave a witty name because I have to stay on brand for myself, that ends up being about 160 lines of code. It is a drop-in request replacement for what I needed to be able to get, post, put, etc. You know, basic HTTP functions you need, including the JSON decoding and all that. It's only 160 lines. I can put this right next to my file. And even, you know, all I have to do is update the imports at the top and say, you know, instead of importing base URL session from request toolbelt, I can import from my other file and get the same thing. I don't have to change the rest of the way that everything else is called. But was this a good idea? Maybe. Did it fix the problem? Maybe. I don't know. Did I ship this? I don't remember. This was at least 3 months ago. It's in the deep archive. But this is really a balance of technical debt. Putting something like this out there, tech debt. Putting tens of thousands of lines of some vendored code in your repo, definitely tech debt. Calling somebody's lambda layers that you have no control over, probably very risky. Or could be, who knows? So this is probably a ticking time bomb. Was it secure? Who knows? Is it doing verification of you know, the remote certificates? Who knows? But at the end of the day, we've got our happy users. They're able to access their internal tools. And we've punted this to be a problem for another day. It's at least not going to be a problem until 2029. Or maybe that's the last date. Well, you know, we can move on to thinking about YUL, I don't know, something like that. So really, like, this is a rapidly evolving situation. Like, I just want us to think about how we use these LLM tools, and really not just how we use them, because even if we're using them responsibly, there's going to be somebody else that we work with that maybe doesn't have the same restraint that we do. We got to look in the mirror and question, are we doing the right thing? Should we properly pay off tech debt? If we pay off some, is it okay to introduce some more? But I guarantee you that somebody you work with is using these kinds of tools, not paying exact attention to what they're doing, you know, living that vibe coding lifestyle. You can maybe easily spot it by the unnecessarily complex code, the huge rewrites for no reason, 0 comments. Comments that are this long, telling you what's going on, that like people who have never put comments in their code ever before start doing. And just really the #1 sign of, you know, this vibe coded infrastructure where the commit message is just this emoji. So really kind of wrapping up, I want us to recognize what these tools are good at, which is small changes, tools and languages that researchers use a lot, Python, SQL, that kind of thing. If you're using like Golang and obscure libraries, like maybe next year it'll be okay, but you're going to be tripping over stuff all the time. So please don't do that. But use these tools to accelerate yourself. Don't ship things that you don't know how they work. You can learn from them, but understand what you're doing. Our goal is not to be an expert prompter. Our goal is to be a more effective engineer. So that, we are late for lunch, and I'm very sorry for that, Matt, and everybody else. But, you know, we just have to ask ourselves a question of, are we doing the right thing or not? And I look forward to seeing everybody next year in somewhere. And if you are interested in working on these kinds of technical debt introductions and much more payoffs of technical debt, my organization is hiring. Please come talk.